Welcome to the next series of our tutorial on decimal to binary conversion. Now the second method involves successive division. And so let's go over the three examples that we did using the second method. So this allows us to confirm our answer. So in the first example, we said that 75 is equal to the binary number 1001011. Let's confirm that using successive division. So here's what you need to do. Start with 75 and divide it by 2. 75 divided by 2 is 37.5. So what this means is that it's 37 remainder 1. Now take the 37 and then divide that by 2. So 37 divided by 2 is 18.5. So that's 18 remainder 1. Then take the 18 and divide that by 2. 18 divided by 2 is exactly 9 with no remainder or remainder 0. And then 9 divided by 2 is 4.5. So we say it's 4 remainder 1. And then 4 divided by 2 is exactly 2. So it's 2 remainder 0. And then 2 divided by 2 is 1, exactly 1. So 1 remainder 0. And then finally, 1 divided by 2, that's basically 0.5. So we could say it's 0 remainder 1. And then we stop here once you hit 0. So at the bottom, you have the MSB, or the most significant bit. At the top you have the LSB, or the least significant bit. Now the way you read it is from the most significant bit to the least significant bit. So basically from the bottom to the top. So look at the numbers that we have. So we have a 1, a 0, and then a 0, 1, 0, 1, 1, which is basically the numbers that we have there. So if you write it from bottom to top, it's 1, 0, 0, 1, 0, 1, 1. And so that's how you can get the same answer using successive division. Now let's go over this second example. So let's say we have 142. Using successive division method, let's divide this by 2. So 142 divided by 2 is exactly 71. So it's 71 with a remainder of 0. And then 71 divided by 2, that's 35.5. So it's 35 remainder 1. And then let's take 35 and divide that by 2. So that's going to be 17.5 or 17 remainder 1. And then 17 divided by 2 is 8.5, so that's 8 remainder 1. And then 8 divided by 2 is exactly 4, so that's 4 remainder 0. And then 4 divided by 2 is exactly 2, so 2 remainder 0. And then 2 divided by 2 is exactly 1, so 1 remainder 0. And then finally, 1 divided by 2 is 0.5, so that's 0 remainder 1. So we're going to read it from the most significant bit to the least significant bit. Going from the bottom to the top. So it's going to be 1, 0, 0, 0, 1, 1, 1, 0, which if you go back to our last tutorial, you'll see that we had this answer. Now let's work on the last example. 339, so let's divide 339 by 2. This will give us 169.5 or 169 remainder 1. And then divide 169 by 2. And so that's gonna be 84.5 or 84 remainder 1. And then 84 divided by 2, that's exactly 42. So 42 remainder 0. And then 42 divided by 2 is exactly 21. And then 21 divided by 2, that's 10.5. So it's 10, remainder 1. And 10 divided by 2 is exactly 5. So 5 remainder 0. 5 divided by 2 is 2.5. So that's 2 remainder 1. And then 2 divided by 2 is exactly 1. And 1 divided by 2 is always 0.5. So that's always gonna be 0 remainder 1. So let's go from the most to the least significant bit. So starting with the number on the bottom, it's going to be 1, 0, 1, 0, 1, 0, 0, 1, 1. And so this is 339 as a binary number. And so that's it for this tutorial. Now you know how to convert decimal numbers into binary numbers, using the two unique ways of doing it. Thanks for watching.